Good morning, everybody. I just wanted to go over a few things from these new sections, just to point a couple things out, tell you to watch for a few things, and make sure that you're ready to do the homework well. So let's just start out with a quick review over what we've been learning. Chapter 6 is about polygons, and we've specifically been talking about quadrilaterals, which are four-sided polygons. And the first kind of four-sided polygon we talked about were the parallelograms. So I know we've gone over this many times, but I told you I was going to beat it into your heads. There are 5 things you need to always remember about parallelograms. Their opposite sides are parallel, their opposite sides are congruent, consecutive angles are supplementary, opposite angles are congruent, and the diagonals bisect each other. Anytime you have a parallelogram, these 5 things are going to be true. Now on Thursday, we talked about 3 types of parallelograms. Those were the rhombus, the rectangle, and the square. Because they're parallelograms, these 5 things are always going to be true. But for a rhombus, they have a few other things that are true. They have 4 congruent sides, their diagonals are perpendicular, and their diagonals bisect a pair of opposite angles. We also learned about another kind of parallelogram, and that was the rectangle. Again, because it's a parallelogram, these 5 things up here are always going to be true for rectangles. Plus, they're going to have 4 right angles, and their diagonals will always be congruent. And then we learned about the square. It is also a parallelogram. It is also a rhombus and a rectangle. So because it's a rhombus, it's going to have 4 congruent sides. Its diagonals will be perpendicular, and its diagonals will bisect a pair of opposite angles. It also has 4 congruent right angles, which make it a square, so its diagonals will always be congruent. So I'm going to pan out just a little bit, and y'all make sure you have that in your notes. Make sure that you know that. And you can pause the video if you want to write it down. Now, I don't know if you remember, but I think it was in 6.2 we learned about these things about parallelograms. And then 6.3, it was like the converse of all those. It said, if both sets of opposite sides are congruent, then you know you have a parallelogram. If both sets of opposite angles are congruent, then you know you have a parallelogram. So today in 6.5, we're going to do that whole converse thing again, but just for the rhombus, rectangle, and square. So turn in your books to page 383. Again, you can pause the video anytime you want, but I'm just going to keep going. So here's our first theorem. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So I'm going to go back over to my chart. I hope I don't make y'all seasick. But remember, here's the rhombus. And one of the things that a rhombus will always have is that its diagonals are perpendicular. If you have a rhombus, you automatically know the diagonals are perpendicular. Well, in 6.5, we're doing the converse of that. So this is saying, if you have a parallelogram and its diagonals are perpendicular, then you know the parallelogram is a rhombus. So here they tell you it's a parallelogram. They tell you that AC is perpendicular to BD, so you automatically know it's a rhombus. Okay, here's the proof of 6.16. Let's just take a minute to go over it. It'll be the only proof we do today. I hope I'm not making y'all sick with this. Okay, so they tell you that ABCD is a parallelogram, and they tell you that AC is perpendicular to BD. So I'm just going to mark that. AC is perpendicular to BD. So all these are perpendicular right here. Okay, so we want to prove that ABCD is a rhombus. And by definition, a rhombus has 4 congruent sides. So we just want to prove that all 4 sides are congruent. So, since ABCD is a parallelogram, by definition, we know in the list of these 5 things that parallelograms' diagonals bisect each other. So go back to this. If their diagonals bisect each other, then BE will be congruent to DE by definition of bisect. They told us that AC was perpendicular to BD. Since they told us that, AED and AEB, AED and AEB will be congruent right angles. And you also know by the reflexive property that AE will be congruent to AE. So these two triangles are going to be congruent by side, angle, side. Side, angle, side. You know by CP-CTC, corresponding parts of congruent triangles, that AB will be congruent to AD because they're both corresponding parts in those triangles. So you know that they will also be congruent. Now, this is still a parallelogram, so let me move this back over here. And you know because it is a parallelogram that opposite sides are congruent. So let's go back to this. So AB will be congruent to CD, and AD will be congruent to its opposite side, BC, because it's a parallelogram. So look, you've got all four opposite sides congruent. AB is congruent to DC, congruent to BC, congruent to AD. So by definition, ABCD is a rhombus. Okay, two more theorems. Theorem 617. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So I'm going back to this. Here's my characteristics of a rhombus. A rhombus has diagonals that bisect a pair of opposite angles. So if you have a parallelogram whose diagonals bisect a pair of opposite angles, then you know you have a rhombus. So that's all that theorem is saying. If ABCD is a parallelogram and 1's congruent to 2 and 3's congruent to 4, you know you've got a rhombus. In 618, that theorem says if the diagonals of a parallelogram are congruent, then the diagonal, If the diagonals of a parallelogram are congruent, then that parallelogram is a rectangle. So they're telling us we have a parallelogram, and they're saying that AC is going to be the same length as BD. If those two diagonals in a parallelogram are congruent, then you know you have a rectangle. Okay, so let's just look at problem 1. I'm not going to do A and B because those are in the book and you can read those. But I do want to look at the got it, number 1. A parallelogram has angle measures of 20, 160, 20, and 160. Can you conclude that it is a rhombus, a rectangle, or a square? So let me draw a parallelogram quickly. So it has 20, 160, 20, and 160. And that's all that they tell us, besides the fact that it is a parallelogram. Okay, so they're asking us, is it a rhombus, a rectangle, or a square? Okay, so let me go back to this chart. I can rule out that it's a rectangle because a rectangle has to have 4 right angles. So I know it's not a rectangle. And I can rule out that it's a square because a square also has to have 4 right angles. So I know it's not a rectangle or a square. It could be a rhombus. We know it's a parallelogram. We don't know if it has 4 congruent sides. We don't know if its diagonals are perpendicular. And we don't know if the diagonals bisect a pair of opposite angles. So all we can do is say it might be a rhombus. We know it is not a rectangle. and we know it's not a square. But we cannot say for sure that it's a rhombus. Okay, now part B in the Got It says, suppose the diagonals of a quadrilateral bisect each other. Can you conclude that it is a rhombus, rectangle, or square? So if diagonals bisect each other, that's in my list of parallelograms, of things that a parallelogram does. So if they tell me the diagonals bisect each other, I know it's a parallelogram. But that doesn't get any more specific to let me know if it is a rhombus, a rectangle, or a square. So no, we cannot say if it's a rhombus, rectangle, or square. All we can say if the diagonals bisect each other is that we know it's a parallelogram. It could be a rhombus, rectangle, or square. It might not be though. We don't know. We don't have enough information. Okay, let's look at problem number 2. I do want to look at this one quickly. It says, for what value of x is parallelogram ABCD a rhombus? So let me go back to this chart. I hope I'm not making y'all sick by going back and forth. But we know it's a rhombus. A rhombus is a parallelogram. It has 4 congruent sides, its diagonals are perpendicular, and its diagonals bisect a pair of opposite angles. The theorems that we learned today are 6:16 and 6:17. And 6:17 says that if you have a parallelogram where the opposite angles are being bisected, then you have a rhombus. So if this angle B is being bisected, then we know it's a rhombus. So we can just say that if the measure of angle ABD is equal to the measure of CBD, if those are 2 congruent angles, then we have a rhombus. So they just sat 6x minus 2 equal to 4x plus 8 and solved it. So if x equals 5, then you know you have a rhombus. Okay, I want you all to try Got It number 2. You pause the video and try that one on your own. So go ahead and pause it now. And I want to show you 2 different ways to work this one. For what value of y is parallelogram DEFG a rectangle? So theorem 6:16 in your book said, no, 6:18. 6:18 said, if the diagonals of a parallelogram are congruent, then you have a rectangle. So there's 2 different ways to work this. If these 2 diagonals are congruent, then we have a rectangle. Well, remember a rectangle is a parallelogram, so these things bisect each other. So if this measures 5y plus 3, this is also 5y plus 3. If this is 7y minus 5, so is this. So you could set it up where you say 2 times 5y plus 3 equals 2 times 7y minus 5. Because if you have 2 of these would make the whole diagonal, and it will be the same length as 2 of these to make the whole diagonal. So if you solve this, you've got to distribute the 2. 10y plus 6 equals 14y minus 10. I'll subtract 10y from both sides, and I'll add 10 to both sides. So if y equals 4, you know your diagonals would be congruent. The other way to think about it, and it's really kind of the same thing, but if your diagonals are congruent, and they bisect each other, then you know the little halves will always be congruent, because they'll be, if they start out congruent and they're both cut in half, then your halves are going to be equal. So you could have also set just 5y plus 3 equal to 7y minus 5. So subtract 5y from both sides. 2y will equal 8. So y will be 4. Either way you want to do it. Okay, y'all can read problem number 3. And then that is all for 6.5. Do the Math Excel assignment in there. And I will send you another video for 6.6. Let me know if you have any questions on 6.5.